Are we back? Are we rolling?
We're back.
Yes. So, yeah, our next guest, a bit unusual because
Why?
most or many of the guests I knew longer than you, but I think you knew William longer than I did, right?
I don't know, because I know actually this is a generation. I can know William's dad. So I think we have to get Michael up here sometime.
Okay, yes, for sure.
Yeah.
So I met William through our dear friend Leanie, who used to live here. Leanie introduced a long-haired gentleman, and we met at a convention. And we just sort of kept in touch. Super smart guy. And then, of course, I told him about AI Tinkerers. Hey, why don't you come on board? So he's sort of part of our inaugural core of members, along with Jeremy and Ivan and Timothy, of course, and probably some other people that I've forgotten to mention. So yeah, we've all been together since the very beginning, and he's taught me some things. So remember, in our previous podcast, we talked with Ronald about expert systems and LLMs and how they're different. So I learned from William actually that LLMs, while we say they're probabilistic, they're more like seeded probabilistic, meaning you can repeat what they generate under certain conditions. That's it. So William has very deep knowledge.
Let me tell you how I know William. Yeah. So I was, at least, as you know, I work at the radio. So I'm always looking for interesting guests to, come in and have conversations. And I always look for what is trending, what is going on. And AI is the topic. And, but I just haven't been finding very interesting guests because I thought a lot of people who claim that they do AI, they just talk and sell training course. And so one day I was talking to Michael. I was like, Michael, you're in computer security. He's a big computer security expert. So I was, do you know any good AI people? And he thought about it and he said, yes, but I'm not sure he speaks Cantonese. And that's William. And because I know William, we're talking, and one day he told me, hey, do you want to meet more AI people? And then I came to AI Tinkerers, and who actually call me.
Hey, Tanya, what's going on?
I was like, what?
Crazy.
Yeah. So
years in the making. I mean, it really was sort of like me meeting William was sort of that way to sort of loop back and just to see and meet you again. And then now we have this podcast, so it's spectacular.
So it's like people meeting people. Exactly. And I think this is going to be interesting. So, I'm talking to William, and I know that you're very busy, and you really rushed to get here. Yeah. So what do? You're a computer scientist. You're one of the real computer AI scientists that I know in Hong Kong.
Yeah, I guess. Like you say, I'm a computer scientist, but I specialize in AI. So, I was doing AI since I was in high school.
Because you have a very unique position because your dad is actually one of the computer security expert in Hong Kong. Is it why you're surrounded by computers? And
I think that's why I was surrounded by computers. But also I was very lucky where at my school we had programming classes, right? So that helped a lot. Got me interested in doing computer science, and then I went and did that at university. I specialized in AI, and then, I was doing AI in high school as well.
So, how many years?
In total, maybe 12 years.
Well, most people only discovered AI maybe the last, last 5 years.
Yeah. But I've been working in the field before, GPT took off. I was,
Do you see a huge difference? Like now, almost everyone is talking about it, whereas before it's just like you work in mysterious stuff.
Oh yeah, there's a lot more. I think I think people believe in AI a lot more now, but there's also a lot of people who pretend, as you say, to know what they're talking about, and they really don't. And then there are also, because everyone is hyping this up so much, people expect AI to be magic, and it's really not, right? So,
for instance, like let's start with one. I will ask Seedance.
Yeah, Seedance. Yeah.
Is that like now, like end of film industry? No one need to shoot anything anymore.
Well, no. I mean, there are lots of things that you can use tools like that for, right? Like you can use that for, well, first of all, the artists and the writers' unions and things like this, they're not going to like it, so they're going to like riot, right? So that's number one. Number two is, other than using the thing to develop, like build the final product, right? You can use it in pre-production, for example.
So
like storyboards.
what we call like previs, right? Or even just storyboards.
Yeah, you can like animate all your storyboards and see what things will look like. Or you can, to test the barrier to entry to become a writer or a director is much, much lower now, because you can like sort of, like before this you had YouTube where anyone could broadcast their own ideas, but you still have to be like a good editor, again, like good with a camera, good with right? Now you can sort of not only get your voice out there, you have the distribution, but also you have the tools in order to be able to, lower the barrier to entry. So hopefully we get a lot more creative stuff out there, So I think there's just going to be a lot more content, a lot more movies, a lot more everything. The problem is going to be, how do we handle having so much entertainment, right?
I would say that probably curation.
Curation, yeah.
I would say that, like with fake news, people starting to understand what a good news editors is about.
You think so?
I think so. I think because I grew up from the good old days of newspapers where there's good news editors,
yes.
Reporters with integrities, and there's a brand that you can't screw it up. And now the legacy media has its own trouble, but I would say that now people start talking about, hey, like news you can trust, or certain people, and it's the same with film. Like there's so many content out there, you kind of have to have good recommendation, even though you don't really know where it comes from, who you can trust.
Yeah, I suppose. Yeah, I mean that's sort of the.
This is a type of curation.
Yeah,
I'm curating with org, like who org thing is the non-bullshitters, right?
I think, and Willem can probably tell better than me. So yeah, for sure. Yeah.
I think that's sort of you hear about the attention economy, and like the influencers like Mr. Beast and them are starting to create their own products and that, right? Like the reason why that works is basically because they have a trusted audience. They build up trust with people who watch them, and then if you're sort of a good content creator, you'll make a good product to sell to your audience.
I hope that we're a good content.
Or you do the thing that a lot of people seem to do, which is they sort of, some company approaches them and they're like, hey, let's do a collaboration. They make a product that's subpar, and then they burn a lot of the trust that they have with their audience and things. So it goes back and forth. But then you also have this problem where you have, because you don't know who to trust, like who do you pick? It tends to be just who agrees with you more and who you like more. People just go off of vibes. I'm worried. So otherwise, you end up with a bunch of people just like, oh yeah, Joe Rogan's like my news source. Like, oh, I don't know about that one.
Yeah. But
so William is very unusual because you introduced yourself to me as a researcher. Right, so like I'm more of an applications guy. So what are some maybe areas of research that you're really interested in now?
At the moment, I'm still really interested in the latent space of these models. So for listeners who don't know, when you have these large language models, people say, all these AI models, people say, that's a black box, right? So well,
Yeah, if anyone who doesn't understand what the black box is, we actually did talk about in, I think, the first episode.
Yeah.
So please watch all the episodes and please give us a like and subscribe and comment. So I'm not going to go to that. Okay, go on.
Yeah, so there's, I mean, Yann LeCun would disagree, but there's a world model that's built inside of these AI models, right? So if we look at language models, which most people are familiar with, okay, the way that they work is basically they just predict what is the next word, basically, right? Now you think, okay, well, that then it can't be smart. It's just predicting the next word. But if you think about it, the reason, what it's actually doing is like, say the sentence is, oh, the capital of France is, right? Well, then you need to know that the capital of France is Paris in order to be able to fill in the word, right? So by basically reading and reading and reading and reading and reading, these models are building a world model, like some concept of the world.
But I mean, even for human, I think we do predict what it is. Like, oh, that's how we save ourselves time. So this is why, you know, in reading, you say you can read the first English letter and the last letters. It basically, you don't read the whole, all the letters in the words.
Yeah, humans don't. That's like, yeah, we take a lot of shortcuts. Humans take a lot of shortcuts. But then the AI takes a lot of shortcuts as well.
So I would say that, like, you know, by predicting the capital of France is Paris, that is actually like how humans sometimes, if you know something really well, you do that type of quick predictions as well.
Yeah, I get what you're saying. The reason why we do it, the reason why we do that in the AI space is because language is really easy. Because like, the problem with AI has always been you don't have enough labeled data, right? So there are two classic problems in AI, right? The first is that you don't have enough labeled data. Like data is really expensive, right?
What do you mean labeled data? Other people might.
Well, okay, so when you have an AI model or a neural net, right, or whatever, right? The idea is that, okay, well, these neural nets, by having enough input and output pairs, so your inputs and what you expect the output to be, then the AI can learn how to map the inputs to the correct outputs that you want. Right?
Yeah.
And basically in the 70s, someone proved that, oh, you know, if you have a sufficiently large one with enough data, you should be able to model anything. Right, any function. Right? They proved this in the 70s, and then everything else after that has just been engineering, pretty much, and like tricks and mathematical efficiency and things like this. But yeah, so the problem is you couldn't get enough input-output pairs.
So is it like it's the same with people say if you have like enough time, you have a room of monkeys, they would be able to type Shakespeare?
Well, that's cheating. But no, it's like I don't know, like any kind of predictive task or classification task, or like say you have a whole bunch of photos that have like dogs and cats, right? You need to know which photo has dogs and cats in order to be able to give it to an AI to be able to figure out what a dog and a cat looks like. Yeah.
Right? So yeah, neural nets were good at sort of solving those functions that didn't have a discrete solution.
Yes, So the power of, yes, that's exactly right. The power of the neural net is given enough input and output pairs, you can model any function, even if you don't know what the function looks like. Right? So the problem has always been, well, you don't have enough data. So the classic way you would do it is you would be a professor, and then you would have a class of students, and for homework, you would give them a whole bunch of photos to label, right? But even then, like this was like even when you had free child labor, right? Like this is still expensive, right? You would always
right now we say that it's probably some village in India that there's a bunch of people
they do that. Yeah, Facebook hired the dude who sort of pioneered turning that into a business. For like
it's
billions
insane.
of dollars. Yeah, but so the classic problem has always been just you don't have enough training data. You don't have enough labeled data, right? The second problem is, well, you don't know what features you need. Like, so in the AI model, you have inputs and you have outputs, right? But for what, like say you want to teach an AI to drive a car. Right? You don't necessarily really know what input data the model needs to be able to learn how to drive a car. Because, for example, it's not immediately obvious to you that you need to know how light reflects off of different fabrics in order to be able to tell the softness of a thing. So you can drive through a plastic bag, but it's not okay to drive through like a traffic cone or something like that. So, like, these are like really, really like things that humans,
how would I know?
Yeah, how would you think to like, oh, this needs to be added to the training data, right? And so the OpenAI breakthrough was basically, okay, well, we'll solve the problem of not knowing what data we need by just giving it all of the data. And then we'll solve we don't have enough labeled data by making it just predict the next word, because then everything is automatically labeled, right? Because your label for one bit is just the next bit, right? So that's what they did, and they scaled, and then they were like, oh wow, this works. And now we have GPT, and now we have and Qwen and DeepSeek and all these guys as well.
It's like they also, that's what they did with was it OpenGo? Is it what it go like with a Go player? Like AlphaGo.
That was different.
That was different?
That was different. That was reinforcement learning.
Even though when they they didn't actually because when you do international chess, you actually already play the whole game. So they had the whole game work out. That's how they win.
Yes.
But whereas wasn't it with AlphaGo that they only predict the next 6 steps. So they didn't actually predict the whole game. So that's how they saved. It's how they be able to actually do it.
The problem with the reason why Go was so difficult was because with chess, like you're right, you're exactly right. Like chess, you can pre-calculate every possible move and find the best move for any possible position, any state of the board, you can predict what is the next best move, right? Just because you can pre-calculate everything. But Go has so many different permutations that you can't do that, right? So what they did was they basically just took an AI and they said, hey, okay, here are the rules of Go.
And learn 5 million times.
Yeah, just play against yourself. Just play against yourself over and over and over.
Wasn't that in the beginning? They also did that with hide and seek. There was like some AI model that was just keep on playing hide and seek.
I know there was the breakout game.
Oh yeah, the breakout game. Yeah, so I mean, in like the 2010s, the early 2000s, like 2010s of AI, basically everyone was doing video games, and the reason why was because in a game, right, you have a set of rules that you can program, and you can tell the model when, you can tell the AI, oh, you lost or you win, right? Or you have a score and you're like increasing the score or lowering the score, right? So it was really easy to say, okay, well, here are the rules, here are the controls, just play and play and play until you have like the maximum score, or like until you win every time, right? And so that's why everyone was doing games. But then I guess people realized that wasn't very useful. so
I want to bring things back to the France-Paris question, because I think it's related to the debate between knowledge and intelligence, right? Like, is there, what we've seen so far is as we feed more and more data, these models get more and more intelligent. But now we're trying to slim down the models again, right? And still make them behave intelligently. Does that have anything to do with your latent space research, or what is your thoughts?
Actually, yeah. So one of the pieces of research that I did was I was trying to figure out, okay, well, if you want to increase the amount of information or the intelligence, they're kind of mixed together. Yeah, they're separate things. They are separate things, but there's inside of the model, they seem to be like mixed together. Exactly, you can't, right? There are techniques that you can probably do. It's a different branch of research. I'll talk about that later.
Yeah. So I was about to ask them about the latencies. So yeah.
Latent space.
Yeah. Latent space. So you like so you're talking about like I'll just ask the questions that is a different branch of research.
The problem is like all these different branches of research sort of like cross over, and you get like these Avengers moments where like everyone comes together and you're like, oh wow, everything works. but then you have to like still build the individual branches of research on their own before they're ready to come to come together, right? So Org was asking about the intelligence,
knowledge and
knowledge thing. Yeah, so I was trying to figure out like, okay, well, if you want to add more domain expertise to a model, right? How could you do that efficiently? And at the time, everyone was using fine-tuning techniques like LoRA, where basically you're simulating training the entire model without training the entire model, right? So
what do you mean? You train a little bit, pretending like to scale?
So these models have like lots of layers inside, right? And then each layer has its own weights. And then basically what LoRA is doing is like, okay, we'll just take a separate neural net and then we will put that in between every layer, and then we will
do a little bit? Do a try run?
No, they're training a separate neural net to be able to map the output of every layer such that it produces some output that you want. It's just learning a general mapping function that applies to the entire model.
Like a trial run in some way.
It's like figuring out the specific bits of the model that needs changing.
Yes, that's right. Yes, that's right.
So it's a very efficient way. I mean, I learned that from you, like low rank adaptation. I had not tried it. I guess Jeremy might be playing around with that.
Yeah.
And stuff.
Yeah. So people were doing low rank adaptation. Low rank adaptations is referring to some like matrix math that we don't need to get into. But basically the idea is that you can learn which bits of the neural net is more important, and then change those to get the behavior you want. But the problem was it didn't seem to really work for knowledge. Like it just didn't work for knowledge. And like, we don't know exactly why, but we think it's probably because since it's low rank, right? So you're training a smaller neural net to be able to figure out what's important in the bigger neural nets. Because you're always trying to figure out what's important, you end up hitting the high abstraction stuff in the model. So you end up changing things like behavior. Right? Things like tone stuff, like stuff that's like higher level, more abstract, right? Because those are the things that produces the largest impact on the output, right? Whereas if you change things that are to do with knowledge, your output change is probably not so big. So
I remember one of our first conversations was you were trying to do some kind of brain scan, but for LLMs, right?
Yeah.
To figure out what parts would light up when certain inputs were fed in.
Yeah.
Was that right?
Yeah. So that's what I did. I took some domain some data. I think it was analyst reports like for finance, and then I fed them through the model to do.
And then you run a theoretical MRI for.
I ran basically an MRI to figure out where inside of the neural net it was thinking the hardest. And then I added more neurons there, and then trained only that area, and it seems to work. And then Alibaba built on top of this, and now my research is useless. But they built on top of my research, which is pretty cool.
So
what does that have to do with sparse versus dense? Does it have anything to do with it?
Oh yeah. So
well, you guys are throwing out jargons that people don't understand. So
yes.
So there's two ways. When people talk about dense and sparse models, they usually mean when you have a mixture of experts model or not, right? The mixture of experts is basically an efficiency thing where you say, okay, well, instead of having one gigantic model, which is very expensive to run,
and just do modular.
Yeah, we'll just have many little models, and then we'll have one model at the front that can predict which smaller models you need. And then those smaller models can live on different GPUs, like different hardware. And then that way, the amount of...
You don't have to have one giant GPU hosting this... This all-encompassing model.
Yes, that's right. So you can. So this is what Kimi is, right? Like Kimi takes it to an extreme. They're like a trillion. So for those listening, Kimi is a Chinese model from a company called Moonshot, and their model is gigantic. It's like 1 trillion parameters, right? 1 trillion parameters. And then, but it's incredibly cheap. It's incredibly cheap to run if you use their API. And that's because they have many, many, many very, very small experts inside of the model that they run on lots of different hardware. And then because you're sharing all of this with a lot of different people, then they can get their costs down very low. That's actually why Kimi is so cheap.
It's in real life, it would be like, instead of having one person who knows everything, you just have like 1 trillion different people.
A whole bunch of people
who are expert in a very small task area.
Yeah.
And then everyone share, like, this particular expert only come out whenever someone have a need for it.
Yeah, pretty much.
And it's like Groupon.
It's like Groupon. Yeah. You can share it with other people, and then different people use different resources at different times.
So latent space seems to be quite important, because it seems to me you would need to know the latent space quite well to figure out how to design and light up specific parts of the...
Yeah, and Anthropic's doing a lot of work on this. Like I said, Alibaba built on my work, and so I know that they're doing stuff like this too. But just to finish out the context, right? So when people talk about dense and sparse models, that's usually what they mean. But at the moment, there's a thing with Qwen 3.5, which is Alibaba's latest model, where people have noticed that it's quite... They call it dense, but actually dense is the wrong word because it refers to a different type of model. But basically what they found was these models, right, they have many layers, right? And I was looking at which layers were being used the most. They did something different. They said, okay, well, we will look at the changes between the layers, right? So if you have like 3 layers, right? And the output of layer 1 and the output of layer 2 is the same, then layer 2 was basically useless. Right? So people are measuring this and seeing how much change is happening. And by how much change is happening, you can tell how useful each layer is, right? So what Alibaba did, or I don't think we actually know how they did it yet. I have a hunch, but I don't want to
bet on it.
I won't make bets. But basically, they ended up having a really, really smooth change. So basically, every layer had the same amount of change to the next layer, which didn't happen before. It used to be that there were lots of layers that basically didn't do very much, and then at the end, you had a bunch of layers that did everything.
So it's like in those badly run company, that's a lot of middle managers that who does nothing.
So in the past, you had a whole bunch of middle managers that did nothing. And you had all the people on the bottom, all the people at the top that did everything. Right?
Well, with body as well, like a badly run body, you have like some really small muscles and carrying a lot of weight. And then
do leg day.
And it's like with body that you have like small muscles that's doing all the work, and then the large muscle is lazy, not doing anything, and they overcompensate, and then that's when you overstretch certain muscles. So what the Alibaba team did, whatever they did, was they made it so that basically every layer was useful. And so what that means is very socialist approach.
What that means is the performance of the model punches above its weight by a lot. So the newest model from them, which is open source, and you can download it and you can use it for free. It's a lot more powerful than models that are bigger than it. So I mean, if you're listening, you don't know, the bigger the model, the better it is. Usually. Right?
But it uses a lot more electricity.
It uses a lot more electricity. It's a lot more expensive to run. You need a lot more hardware. And so, the Qwen thing was just impressive.
Well, it's the same with body. If all your muscle works together, then you don't have to, the muscle doesn't have to be very big, but you will actually be able to lift weight.
So one of the ideas I wanted to talk about was with intelligence and world models. One of the theories is, as these models know different types of input, multimodal models, is there efficiencies there because they are processing different things and of that nature? I don't know.
Multimodal model.
More jargon. I'm sorry.
No, actually modal. Where modal came up? Matrix 3. Matrix 4. Then in the beginning, they have modal. Yeah.
I don't
Anyway,
even remember Matrix 4. I watched it. It wasn't a reboot. It was
it was one Wachowski sisters.
one of the sisters.
Yeah. Anyway,
That's right.
so multimodal network. Okay.
Yeah, and then
So what is a modal?
So the idea. So remember when I said we did language because it was easy? Mm-hmm. Yeah, we're sort of, I think, hitting the end of that now, where basically these.
All the existing human data is already all shoved into trained.
Well, that was a long time ago. We ran out of data a long time ago. What we did instead was, okay, we'll start generating data in order to train these models. That's why they got so good, like recently, like in the past year or so. They got so good because we stopped training it on human data because human data sucks.
Yeah, because human data are like sometimes they pollute the data and so on and so forth.
Yeah. So remember when we had the hallucination problem of like it always would be very confidently wrong. One of the reasons why that happened was because it was trained on the internet, and on the internet no one ever admits they're wrong.
I see. Okay.
So right, like stuff like this. Yeah. So we're hitting the end of, I think, how far language can take us, and I can get into why I think this, if you like, later. But basically, I think we're hitting the end of that.
Okay.
And I think the big labs have known that we're hitting the end of that for a while. So what they've been doing is multimodal models. So a modal is basically just different types of inputs. So language would be one, like text would be one. Images, video, different modals. So when you're talking about multimodal models, triple M. I've never seen anyone abbreviate it as a triple M. I feel like that would make sense.
3M, yeah.
MMM.
Yeah, 3M.
You heard it from here.
Yeah, you'd end up with like copyright issues, right? but yeah, 3M, M3. But anyway.
I don't know, we can use it in Chinese. Yeah. San M.
San M. Yeah. So multimodal models is basically the idea that, okay, well, we're going to take like an image encoder. So we'll take image input and text input, and we'll put them together, and then we'll be able to put them into the same model and then output stuff, right?
So on.
And then people have been doing this with audio as well, so that you can have like text, audio, and images. And
maybe we'll have to go to like plant or something that to make it different.
I'm working on it. I'm not joking. I'm actually working on that. Like that.
No, because I think plants and fungi probably have better input and also crow. Actually, crows. Yeah, crows has crows and also like marine animals. You know.
You know who has a really cool data set?
Cool.
The Pokemon Go people. The Pokemon Go people have had like a decade of these people just walking around.
Yes.
We were talking about Pokemon Go earlier today.
Yes. Well, lately, Pokemon Go people and Pokepedia people.
Aye.
Yeah, they are like you like because Pokepedia has been so there's a thing called Pokepedia that is from the like Nintendo studio with Animal Crossing so on, and they first had I think Pokepedia 1, Pokepedia like they had this idea, and then they just launched a thing, Pokepedia, and for some reason the PR and the ads look so horrible, so everyone thought that this thing is going to tank. However, it was a very rich world built by a very good game designer, and all the Pokemon people who always been playing with their Pokemon, they wish that their favorite Pokemon they can buy a croissant or a cafe and decorate this coffee shop for their favorite Pokemon. Finally, be able to do it in Pokepedia, and it's really selling out hotcakes. Anyway.
Yeah. Pokemon as a brand is annoyingly successful.
World models. playing games.
Okay. Yeah. So I think Pokemon is a very. I personally think Pokemon. The reason why it is so successful, it has to go back to its card games. It has to go with the person who invented Pokemon, because he originally, I think he had trouble relating to his friends in school, and he thought that by collecting insects, he can. That's how he make friends, and he come up with this concept in cards, and then he comes up with this concept in game, and then that thing went into Pokemon, and it tapped into community that you never thought it would, and it connect people in a.
Did the cards come out first, or did the game come out first?
The card come out first. The card come out in the 90s.
So did the games.
No, I think the card first.
Okay.
Like the card came out even before the game even exist, I think. Oh, I don't know.
Because the game was the original Game Boy.
Oh yeah, so maybe the Game Boy
was
come
black
out
and
first.
white.
Yeah, so maybe Game Boy come out first. Actually, come to
It was
think
like
of it.
Tetris days.
Yeah, so
Like
yeah, it
original
might be
Tetris
game.
days.
Yeah, it might be Game Boy and then cards and then back to game again.
Yeah.
Yeah. So and then I think in each of the iterations of Pokemon, they have different group of people that got interested in it.
Yeah, I think at the moment, Pokemon, one of the reasons why Pokemon's getting so big at the moment, I think it's just because all the NFT people have gotten into it.
Oh.
It's like all the people who like to collect stuff, and they also grew up with Pokemon, so they're like, they grew up with it, and now they also have money, and they're also like the NFT type people. And then this like resulted in like the perfect storm of.
And also, I think there's
capitalists.
just there's also people that who, I personally, what I think about Pokemon Go, that I think what I would not really say bad things about them, is that I think it really got a lot of people that who might have never able to make friends. You know, people that who has like some problem with like sickness, some issues, who have never have met friends before.
Yeah.
And through playing Pokemon Go, they found that maybe it's that personally that they managed to get through their like, you know, their concern about making friends, because they can have their the concentrations on the game, and then so they find out that they actually can make friends with all these people around the world. Yeah. And I think that's why I think Pokemon is interesting. But I think for is world building and games, right? That's what before you left.
Yeah, because we mentioned Pokemon Go, and I thought
world models.
William loves is looking into world models now, so I thought games are very appropriate for that. Yeah, or just
yeah.
The guy who's working on world models the most is a guy called Yann LeCun, and he was the head of AI research at Meta, right? And he left Meta. He's not happy with Meta because they've decided to just make money instead of do long-term research. There's a whole drama thing that happened there. But anyway, he started his own lab in Paris. It's called AMI, Advanced Machine Intelligence. They raised $1.5 billion. That's not their valuation. That's how much money they got, right?
My goodness.
And then their head of research is in HKUST.
Oh, really?
Yeah, she's a professor at UST. It's their head of research.
So actually, Hong Kong seems to be a town that has a lot of talents.
Yeah, we do. I mean, we also have MiniMax, and that's pretty cool. So for those of you who don't know, like OpenClaw, like I'm guessing everyone knows OpenClaw now, right? OpenClaw is like the super popular thing, right? And it's basically resulted in a lot of people using AI, and I think the most used AI in the world at the moment is a model called MiniMax from a company also called MiniMax. And they IPO'd in Hong Kong. And they have an office in Hong Kong. So like the most used AI people are just here.
And if they're listening?
Yes, I mean...
Yeah, got them on the show.
go to Hong Kong AI podcast, and you guys are welcome, right?
Yeah, we're looking for venues. If they have a nice office, we're happy to podcast there.
Yeah, just like what Orchilab is helping us. Yeah, and also I really think I'm doing this podcast. I didn't even know all these things that in Hong Kong. Like today, and then also Orchilab been telling us that Hong Kong has a lot of talent.
Talented researchers.
Yeah, there is. Yeah,
everything.
So you also think Hong Kong has a lot of talents?
Yeah, I always push the idea that actually we have a lot of talent in Hong Kong. Like Hong Kong has basically every advantage you could want, right? Like you have a lot of capital, you have top talent. Your visa, the visas are really easy to come and go, right? It's an international city, everything's in English, everyone speaks English, right? You have very mature, stable laws.
Well,
you have every advantage you could ever want.
And Neil brought up a very interesting point is that it's from here to Shenzhen is closer than San Francisco to Palo Alto.
Yeah.
Mm-hmm.
So this Greater Bay Area, it has a very unique, even from a geological advantage as well.
Yeah, the Greater Bay Area is quite useful. It's quite good, I'd say.
But what do you think that Hong Kong should what can we do better?
We need to fix our brand. Hong Kong has a branding issue. If you talk to people about Hong Kong technology, especially if you talk to a Hong Kong person about Hong Kong technology,
yes,
they'll say, "What are you talking about?"
There is no technology in Hong Kong. We only do finance. We're a service industry place.
Everyone thinks it's just it's just Hong Kong's just finance. You talk to the VC people, and then they're like, "Oh, there's no tech, there's no talent." You talk to basically anyone on the street. You talk to them about Hong Kong tech, they won't believe.
So what do we have to do? We have to cluster together and then say.
Well, I think we need to be a bit more proud of the stuff that we do, right?
I think it has something to do with the Cantonese mentality that we find it a little bit. What to say? We find it a little bit lame to say good stuff about ourselves. Whereas Singapore,
do you think so? I'm not sure.
When's the last time you say good thing about yourself?
Yeah, but I'm not Chinese. I'm not Chinese.
And then, I think in Hong Kong we like to talk about what is not working in the city compared to Singapore. Singaporean, they like to talk about what is so good about the city.
Yeah, but I think that comes from the pride, right? We just don't. We're just not very proud of the stuff that we do.
No, I think sometimes it's just that we don't know how good we are as well. I mean,
that's what this podcast's for, right?
Yeah,
you got to push the.
Trying to do.
Yeah. I mean, even I think for instance, Hong Kong is probably the original cyberpunk city.
It was,
right?
Yeah.
The original cyberpunk city. It's still very cyberpunk-ish looking city. I mean, maybe you can say some people might argue Chongqing or Shanghai, but honestly, Hong Kong is the original cyberpunk city. And
Ghost in the Shell. But an entire segment of just this is Hong Kong.
But honestly, 1994, when I was living in Paris, and when I think my teacher was telling me, "Oh my God, your city is beautiful." I was like, "Beautiful what?"
Yeah, that's a good point, actually. Yeah.
And then when I looked at Ghost in the Shell, I was like, oh yeah.
Yeah, if you look at media around the world, there's so many pieces of media that's inspired by just Hong Kong.
A lot of films.
The city.
Yeah.
Yeah.
And I mean so even for that, we know is proven. It's proven that we are unique. Yeah. But still we're not very good at talking about that sort of stuff.
Yeah. We should fix that.
But so actually we're doing quite well. We have all the talent, we have the money. We're just not very good at saying good things about ourselves.
Well, that's why it's also frustrating, right? Because you have all the stuff, you just don't you don't talk about it. You're like, okay.
So that's what.
Tali's really good at talking about it, though. So we've got a super weapon.
We're just gonna have a lot of you to come here and just keep talking, because I think another thing is that I think we need to do two things. First thing, we need to talk about how like what are the good stuff that everyone's doing. And secondly, I think is that some of the stuff that you guys are doing is quite advanced. And I think for the public, they really don't know because there's a lot of garbage out there. Just
There is a lot of garbage out
The
there.
so what we really want is have like people that you guys are doing good work come and tell us.
I have an idea for the next time. If she's willing to, talk about the farm project, the mysterious farm project, when you have some...
Oh, yeah.
Yeah.
You can ask, yeah.
Yeah.
Okay.
Very interesting. Mysterious, we'll leave it ambiguous for now, but...
Yeah, well, there's so many things that we want to talk about. And so the only thing is like, please subscribe, please comment, and please share. Because, I don't know, unless we can invent another new way to beat the algorithm, this is the best way for us to pass the word out. And also, if you tell us, come to Hong Kong AI podcast, tell us what you want. And also, if you can support us with venue and,
venues, sponsorship.
Yeah.
Buy
Just any
coffee when it's set up.
Yes. Oh, it has to be set up.
Yeah.
Yeah.
Backlink to us, whatever. I don't know.
Yeah. And so you're working on latency space.
Yeah, latent space, yeah.
And what else? What else you want to talk about? What interesting stuff? Because what you have said, whatever that we read, on the on the public spheres, it seems like those are all old news from 20 years ago. So
okay, let's talk about something that's a bit more forward-looking then. I think that we're sort of hitting the end of text models.
Okay.
Right? We did them because they're easy, but it seems to be that we're not improving the behaviors and the intelligence and the quality of the outputs efficiently.
What we read in the news is that you're trained,
Yeah.
and then there was big leaps, and then now there's last portions that doesn't seem to.
It's difficult to model. Basically, you still have huge leaps, right? But where the huge leaps are coming from is different. So before, you'd have huge leaps in what's called the pre-training, right? Where basically you just train on a lot of data, right? And then this results in a lot of emergent properties. So you basically feed it the internet and it's able to do lots of different things that you didn't expect it to be able to do, right? And then the big leaps came from post-training, right? Where basically you say, okay, well, you have this GPT type thing. We'll find the behaviors that we want this thing to be able to exhibit. And then we'll build data sets around those. They're all synthetic, this all fake data. And they use that to train these models in order to do the behaviors that they want. But it seems to be that everyone's talking about AGI, but these models seem to be really, the generalizing bit seems to have come from the pre-training. And now that I think is just dead. That's done.
Didn't we have a while in the news is always say AGI soon, AGI soon.
Yeah,
we are in AGI.
Yeah, that's not happening. Basically, what's happening right now is you have a whole bunch of people who are generating data sets by hand for very, very specific tasks in order to train the models to be able to be good at those specific tasks, right? And this is why if you train, you know that the giant, the big models like GPT and Claude and all these guys, right? They're really good at code. They're way better at code than any small model that you can run on your laptop, right? But in other domains, and niche domains, the difference is 25%. It's 11 percentage points last time I checked personally for the domains that I'm working in.
Is it because there's not enough data?
No, it seems to be just that the behavioral improvements that we're seeing are coming from really curated, a really, really long tail of curated data sets where you have a bunch of humans just making by hand all this data in order to train the models to be able to be good at doing a very specific thing. But they don't generalize. The generalization seems to be happening from the pre-training. and that's dead. So we need a new approach. There are different people with different ideas on what we should do, but yeah, it seems to be the current direction we're going in is not going to get us to any kind of AGI. So if you're worried about Terminator, like, we're fine.
So DeepSeek OCR, anything promising there, or?
DeepSeek OCR is about information efficiency, right? So, like I keep on saying, I think text is coming to an end. DeepSeek OCR is interesting because it just takes a completely different approach to the input data, where they, instead of looking at text as text, they look at text as an image, right? And it turns out that this is way more efficient. There's just way more information inside of an image than there is encoded in text. And the text just takes up way more data to represent the same amount of information, if that makes sense.
Well, the last, like, wasn't it in films that sometimes we see those, like, spy film, they will say, oh, this is an image, but it's actually a bunch of informations.
Oh, yeah, I know what you mean. Yeah,
It reminds me,
stuff, right? Yeah, it is kind of like that, where the AI can pick up on things that humans don't, or don't think about. I don't think it's true that it can see things that we can't. I think
they can probably see details because they scan things.
Yeah, they can see details that we can't see. But I think there's just a whole bunch of things that we do as humans that we don't really think about, like the spacing. Like, why is spacing so important on a UI? There's just a lot of information there, right? Like, there's a lot of...
Well, and a lot of things that we call intuitions.
Yeah, we call it intuition, but it's real. It's there, right? So,
well, there are some people that are better at this, and some people are not as good at this. So there must be something.
Yeah.
Maybe it's training. Maybe is it genes? We don't know yet. It's very interesting that how as we start working on AI, we're starting to like tap onto things that we used to think are old wives' tales, or
We need more humanities people. We need more like neuroscientists. We need more like psychologists. We need more like economists, more people who like predict human behavior, like that study human behavior. I think that's going to be quite useful if you want to build AI. That makes sense to me.
That's very different than what people normally would talk about, right? They say we need more science people. We don't need humanities.
Well, we do need more science people, but we're always getting more science people. There aren't very many like good humanitarian people, and they don't get valued very much. So we should.
I mean, it's like there's like science and spiritualism in the past does not mix, and people at least like they think that it doesn't mix.
You think so?
No, in the past it doesn't. Most people, like, if you ask like any like my uncles, his generations used to think that, hey, all this they like one of my uncles even refused to try Chinese medicine because he thinks that that's old wives' tale. That's like,
I think Chinese medicine's just the original big data, right? Like you have like 1 billion people all trying lots of different things, and some things work, you don't know why. It's like, okay.
Yeah, and also because like Chinese medicine, you look at the body as a whole, as a system. Whereas like Western medicine, you go, oh, you have a problem in your like fingers, then that's just a localized issue. But the Chinese go, oh, which fingers? That is related to your internal organs.
Yeah, the 5 elements in yin yang, right? That's
so
I'm really excited for when you have AI models that can just scan you and they're like, yep, here's your problem. And you're like, oh, great, thanks. Because the problem right now is like, I mean, doctors are great and they do great work, but if you don't get the doctor who happens to have the correct idea of what's wrong with you, you could just never get diagnosed properly. So you have to go to multiple doctors, and like it's just a whole thing. So when you have
asking multiple models is a thing now, right?
Yeah, that's true too. But at least you can do it easily and cheaply and in one place without traveling. So. And without making multiple appointments.
I mean, one of the things is that I think for people who, like, I remember, like, for like my aunt, like when I have one of my aunts, and she has something that is not, she wasn't feeling well. So, and in Indonesia at that time, they don't have very good doctors. So when she comes to see an expert, like, in Hong Kong, she was very disappointed.
Really?
Because she's like, the doctor's saying, oh, it could be this or it could be this. We have to actually see, and she was really, she wasn't used to this idea. She's not used to this idea. She was like, how come this doctor is not very sure? Shouldn't he actually just know, like God, like the oracle that you're supposed to get this? And I think for most doctors, if they are friends with you, they'll go, we are 75% sure that you are this. Yeah. And then you're like, aren't you guys always sure? How the hell?
That's the correct approach, though.
That's the correct approach.
We can actually loop this back into AI because GPT-3, like before ChatGPT, right? Because ChatGPT was built on top of GPT 3.5. GPT 3.5 was just a model that they trained on the internet and code, right? And you could argue that 3.5 was better than ChatGPT, like the original ChatGPT, because the original one used to do the thing where they were like, oh, it could be this, it could be that. We're like 70% this, 30% that, like, right?
Whereas now it's like, I can 100% sure that this is it.
But do you know why?
Why?
Exactly as you say, because people like that. So when how they made ChatGPT was they hired 40 people, and then all day for 8 hours a day, they would just sit and they would see 2 outputs and they would pick which one they like more. And then people just picked the one that was more confident. So that's another reason why we had hallucinations.
But maybe they didn't pick the correct 40 people. Yeah, because because Steve Jobs always said that you cannot trust the public to tell you what they want.
Yeah.
You kind of have to.
Yeah, but you have to show them, right? And I suppose in a way they did show them.
No, but you cannot trust the general public to tell you what they want. You kind of have to have your own experience to know that what the general public needs.
Yeah.
So what they want and what they need is very, very, sometimes can be very, very different things, because especially what they want in this second might not necessarily be what they need in 3 days' time. And also because the general public, wasn't there a saying like one person is smart, like a whole group of people, they are idiots. So the crowd sometimes, they go with trends.
That's George Carlin.
I want junk food, but I need oatmeal, right?
Yeah, and also I think because when you want junk food is because you don't think of the consequences. Yeah. But if you know the consequences, you probably will want oatmeal.
But I would think so going back to the AI part, I would think that it's harder for AIs to hedge because they have to come up with sort of two answers, right? Rather than just converging on one, which is whatever their most common answer would be. So I would think that and actually that's what I would want. I would think I would want hedging, but I guess since people didn't like it,
people didn't like it. Yeah.
No, I think for the more like when you have even in university, right? When you have the more like the people who are in advanced research, when you have a discussion, is always going, I think it's like this, but I'm not quite sure. Mm-hmm. But when you're facing the public, you go, this is the thing you want, because it's a two set of different,
goals. Different goals.
So maybe when it comes to large language model, there has to be that too. Mm. And I mean, I don't know. It's like, it's the same with I remember when I was little, the Chinese cultures, right? Chopstick makes no sense to me. I was like,
really?
Yeah.
Elegant.
I would be like, why? If I can eat, I would want to eat it with my hand.
Oh.
I mean, why do I have to learn how to maneuver with these 2 sticks in order to eat a meal? But when you grow up, you realize, oh my goodness, what an elegant tools, how it actually, how it changed my behavior at eating, and it actually teach me constraint, and like it teach me restraint, and it teach me manners. But that's the things that you would only know later. But if we go with the general public and your first instinct, then everyone will be eating with just their hands.
Well, you get TikTok, yeah.
But I mean, if we have time, I did want to talk to William about sort of, when I was using his service, the way that it was generating articles, they felt human. They sort of had like a composition. It wasn't just a standard summary. So I'm very curious, like how you went. We talked about this a long time ago, but I'm just curious how you were able to sort of get that out of whatever your complex data pipeline was. Like,
yeah, so we were doing a lot of like finance stuff, right? So we were like, okay, well, if we wanted to sound like the finance like people, basically instructing it to do so was not good enough. So we had to train our own models to do it.
I see.
And then the data pipes were like a whole thing. The data pipes were a whole thing. There's like a big, like live updating vector thing that's happening where things are being summarized and clumped together, and there's a whole load of live updates that happen on the data side. But once all the data's ready, which is really the hard bit, then it just was just the language model was able to do a lookup through our live database of everything that was happening. We have an events database, basically. Mm-hmm. So basically, for listeners who don't know, I mean, no one will know, but my company, we built a data pipe that was taking in all of the things that people were talking about on social medias and like group chats and things like this. And Google you couldn't search this stuff on Google because Google's PageRank algorithm just doesn't work for this type of data. So we were like, okay, well, we should be able to build a custom system that can handle it all. So we had a thing where you just had a fire hose of text messages coming in and Twitter posts and Reddit posts and all these things coming in. And then on the output, you had just a live updating events list, basically. And then the AI model, like the language model, would be able to look at this live events list, see what's going on, basically tell you about it. But the behavior, like what it sounded like, that just came from we trained it to do that.
I see.
Yeah.
Because the way me at the application layer, the way I would do it is I would have a series of basically searches and then assembling context and then having a very nice prompt to assemble a nice article. But I think the way you did it was more, you just went straight to the model and you just had a great model able to just write articles naturally.
Yeah, it was really small as well. It was like it would run on a laptop.
Oh, wow.
Yeah, it was good. Yeah.
Okay.
Well, happy times. Like it's an hour already.
Oh, okay.
Yeah. Please come back again.
Yeah, sure.
This is fascinating, and I think we need to we need to know how good we're doing and how well we're doing.
Gotta remember what we talked about.
No, I'm just saying that please subscribe.
Yeah, subscribe. Thank you, Oculabs.
And thank you, Oculabs. And if you want to check out more videos, we have quite a good list already.
Yes.
Remember to comment and
The description will have all the links of what we talked about.
Yeah, and also you can actually go to Hong Kong AI Podcast website.com.
.com.
And see you soon. One more for Alex.